Welcome everyone to this today webinar about the CanFD Lite ecosystem. Before I start the webinar, I would like to point out some tips about the CiA webinars. This event is going to be recorded. By participating in the event, you agree that the organizer is allowed to take pictures and recordings. Please mute your microphone during the presentations. At the end of the presentation, we will have the question and answering part. Until then, you can also use the chat box if you have any question, not to forget it. My name is Khaghani. I would like to introduce myself briefly. I am educated in electronic engineering, and I've been working in Canon automation since 2023. At the moment, I am the technical manager of some special interest groups such as radar sensors, CanFD Lite test cases, safety and security, and also I assist some other technical managers in other interest groups. What I am going to talk about today is firstly an introduction to Canon automation. Then I would like to introduce about the CanFD Lite, what is CanFD Lite. Then device and system design aspects of the CanFD Lite will be presented, and at the end the application fields today and tomorrow will be discussed. And as I've said, we have question and answering part. Canon Automation. CiA is the International Users and Manufacturers Group that develops and supports CANopen and other CAN-based higher layer protocols. This non-profit group was founded in 1992 to provide CAN-based technical product and marketing information. And the association fosters the image of the CAN technology and also provides a path to future network technologies. And CAN technology has evolved continuously for decades. As you can see in this slide, it shows you the milestone of the CiA history. From the formation of the non-profit association to releasing the first draft specification proposal, the CiA 604-1, that is regard to the CanFD Lite data link layer and physical coding sublayer requirements of responder nodes, which was later withdrawn and submitted to the ISO 11898-1. That the third edition of this ISO document includes the CiA 610-1 and also CiA 604-1. Recently, actually, the fourth edition of the ISO of this 11898-2, which includes the CiA 610-3 and CiA 601-4, was released, and also we have released recently the specification of high bitrate mode for commander and responder nodes as the CiA 604-4. There are several services offered by CiA, such as organizing technical groups and meetings, developing and maintaining CiA specifications, holding trade shows, webinars, international CAN conferences, as well as offering various marketing opportunities such as placing advertisements in CiA publication, joining a CiA at selected trade shows as co-exhibitor or with a product panel, or you can also participate as a sponsor or a speaker of the selected CiA events. About the CiA publications, they vary from the CAN newsletters, magazines, and also CAN newsletter online that are available always in the CiA website, and you can download them easily, to the always updated CiA product guides in the CiA product guides website and also a CiA website, and the CAN community news, which is distributed every 3 weeks, and CiA members receive it as CiA email services. You can be a part of our organization, and being a CiA member gives you this possibility to benefit individual advantages and also general advantages, such as having access to all CiA specifications, including all development stages and background information. Also, participating in CiA technical meetings, you can also have the possibility to discuss with other CAN experts in the technical meetings. And if you have also a CAN product, you can test it by participation in CiA interoperability tests such as plug fests. Also, free of charge can open vendor ID assignment, and also the marketing opportunities are other benefits of being a member of CiA. And generally, this membership gives you the possibility to support international standardization of CAN-based technology. So it was a brief introduction to CAN automation. And now I would like to go in detail about the CANFD Lite. Uh, the first topic of our today's webinar is Introduction to CANFD Lite. What is CANFD Lite actually? And the growing number of smart electronic devices in modern embedded systems created new communication requirements, especially for small monolithic devices such as sensors, actuators, switches, and lighting modules. While these devices benefit from the advantages of CAN-FD, including higher data rates, larger payloads, and also interoperability with CAN-based networks, they often do not require the full functionality and the complexity of a conventional CAN-FD controller. The need for a CAN-FD Lite or the lightweight CAN-FD approach became particularly visible during the development of modern automotive rear light systems. Then, where the need to derive hundreds of the light sources in a dynamic way and safety and reliability requirements plus the cost pressures to the automotive industry extended this scope of this kind of system. Therefore, CANFD Lite was introduced as a simplified implementation of CANFD communication, which is optimized for cost-sensitive and resource-constrained devices. What is the motivation and the advantages of using CANFD Lite? The motivation includes reducing silicon complexity and implementation costs, and enabling very small microcontrollers and simple devices to participate in CAN-FD networks. Also supporting efficient communication in distributed embedded systems, maintaining compatibility with the CAN-FD ecosystem. And as the main advantages of CAN-FD Lite, I can name the simplified protocol implementation, lower hardware and software complexity, reduced power consumption, cost-efficient integration into small monolithic devices, interoperability with CAN-FD systems, higher data throughput compared to CAN Classic, and also support for the modern distributed architectures. In this slide, in order to familiarize you with the CiA specification, there is a CiA 604 series, which have been dedicated to the CAN-FD Lite in the following way. That is the first part, CiA 604-1. Originally, this CAN-FD Lite specification has been developed within CiA. In the meantime, the related CiA document has been submitted to ISO, and now, as I have said in the last slide, it's the base of the ISO document 11898-1 Annex A. And part 3 of the 604, that is a CiA specification. It is related to CAN-FD Lite system design recommendation. Currently, a work draft is available for the CiA members, and the releasing process is already has been started and will be released soon, I think in this year. Fourth part, CiA has developed a specification for high bitrate mode for commander and responder nodes that has been released recently as a draft specification proposal. In addition, the CiA is working also on the ISO 11898-1 clarifications regarding the CAN-FD Lite. They will be introduced into the next edition of this document. On the other hand, ISO 16845-1 conformance test plan will reference some of these clarifications. The conformance test plan of this CAN-FD Lite high bitrate approach will be specified in the part 5 of this series, 604-5, which will be submitted later to the ISO. So it was a briefly introduction to CAN-FD Lite, and now I would like to talk about the device and the system design aspects. As you can see in this photo, which shows you a CAN-FD Lite architecture, the CAN-FD Lite communication uses a commander-responder communication schema. And the commander node controls the entire communication. And also, as you can see in this part, the responder nodes are only allowed to send data frames if explicitly requested by commander node. And as you can also see here in the commander part of this design, the commander can be also the CAN-FD or CAN-XL controllers. And the CAN-FD Lite devices are optimized for small monolithic devices with reduced implementation complexity, such as sensors and actuators or simple control devices. What would be the CAN-FD Lite communication principle? The CAN-FD Lite network consists of one commander node, as you have seen in the last slide, and also one or multiple responder nodes. Achieving bit rates up to 8 megabit per second also is possible when using CAN-SIG transceivers as standardized in ISO 11898-2. And also I can say that CAN-FD Lite does not support bitrate switching, error frames, and overload frames, and also does not arbitrate. It means that the CAN identifier does not determine the bus access priority. Instead, I can explain later, its 11 bits can be used for addressing the bus participants. And it is specified in the CiA 604-3 that is under releasing. In addition, CAN-FD Lite can support three communication models: unicast, multicast, and broadcast. If the data frame is addressed to only one responder node, it is called a unicast data frame. And if it is addressed to multiple responder nodes, it is called the multicast data frame. And in case it is addressed to all the responder nodes in the network, it is called the broadcast data frame. A unicast data frame contains data for the address responder node, or it contains a request to that responder node or both of them. Only unicast data frames are allowed to request responses, and this guarantees that only one responder node answers to a request, and therefore only one responder node sends data over the network. In contrast, multiple and the broadcast data frames do not contain requests for responding from responder nodes, but they only can contain data to the address responder nodes. So, with this strict communication flow, arbitration is not needed, as I have claimed it already. And since the data flow is clearly identified, error frames also are not required. Therefore, in case of using unicast communication, the data flow is unidirectional in case the commander sends a dedicated frame to one device as a responder node. And the address device is the only one to answer this frame. And now you may ask yourself this question that what would happen in case of missing response from responder nodes? I can answer this question in such a way that the commander node is not able to verify that its broadcast or multicast data frames are accepted by all the address responder nodes. But as recommended in the CiA 604-3, the verification should be done on higher layers, and for example, by using unicast response requests to check if the data is accepted or not. To give you an overview of how this communication works, as you can see in this photo, requests from a commander node to a responder node contain usually read or write access to a specific memory location inside a responder node. This written memory data can tell the responder node to set an actuator, for example, as you can see here, that to a specific value, such as that it tells that move a stepper motor, and also respectively, the read memory value may contain information, for example, measured by the responder node, such as position reported by an encoder. It was just a simple example of this communication. And in this slide, I would like to briefly tell about the high bit rate mode of CAN-FD Lite that is specified in CiA 604-4. What would be considered to achieve bit rates up to 8 megabit per second? Higher bit rates in a CAN-FD Lite network can be achieved if the commander node does not use the bit monitoring and does not require the confirmation of acknowledge bit after a data frame is transmitted. Further, the commander node does not need to support error frames and overload frames, and therefore no fault confinement. In this mode, the node can support higher bitrate and is only limited by the used physical layer. It means the reaching up to 8 megabit per second is possible by using CAN-SIG transceivers that improve signal and integrity and enable reliable high-speed communications. Also, a responder node may support a high bitrate mode in a way that no arbitration, no bit monitoring, no acknowledge response, and also no error and overload frames. As I've said, it is specified in detail in the CiA specification. So, to the next slide, CAN-FD Lite is a simplified design. It means that the CAN-FD Lite uses a subset of the CAN-FD protocol, and the easier integration into low-cost microcontrollers is possible with the CAN-FD Lite, and also reduce verification and software effort, and no arbitration, no error frames are needed. Therefore, no need for an external crystal oscillator. To compare with the with CAN-FD, as you can see in this chart, his concept helps the manufacturers integrate CAN-FD communication into monolithic devices. To go in detail on this claim that no need for external crystal, I would like to give you more information. Actually, a motivation to use CanFD Lite is the possibility to apply a protocol controller clock in the responder node that has lower accuracy requirements than those in CAN-CC or CAN Classic or CanFD nodes. This enables the monolithic controller implementations in the responder node without the need of frequency setting components such as crystals. For example, errors detected by one network participant are announced to the entire network by error frames. Due to their synchronization, these features require an accurate clock that is usually generated by crystal or ceramic resonators. By replacing these features, the crystal and buffer memory, which is necessary in case arbitration is lost, can be removed. That is the reason for standardizing NFT Lite with no arbitration and no frame and no error frames, as I have explained already. So imagine in a specific industry, as you see in this slide, the modern systems require many nodes, which provide sensing and measuring the values to improve an ability such as condition monitoring. Using KNFT controllers everywhere may increase the costs unnecessarily. KNFT Lite enables scalable architectures where this complexity is only added where it is needed. I can say that KNFT Lites enable scalable and cost-efficient distributed architectures. To the topic about the what is the application fields today and tomorrow. Now I can say that it is time to talk about the CanFD Lite availabilities. As you can see in the left side of this slide, CanFD Lite is already being deployed in series production devices. All these digital OLED taillights developed by the companies Marelli and OLED Works, which are used for the Audi model Q6 e-tron and also new Audi Q3 models, which use a CanFD light network to individually control of OLED lighting segments. This demonstrates that the CanFD Lite is not just a concept on paper, but it is proven technology enabling the innovative and highly customizable automotive lighting systems. It is actually, as I have written here, it is part of an article that was published in the Can newsletter of this year at the first edition. And then also, in addition, on occasion of the embedded the world exhibition last year in Nuremberg, the companies Bosch, ST Microelectronics, and also Vector demonstrated their CanFD Lite products. Bosch demonstrated the CanFD Lite responder nodes based on its CanFD Lite IP cores operating at 8 megabit per second using CAN-SIG transceivers. As you can see here, that it was not just on a paper, it was demonstrated last year. And also ST Microelectronics demonstrated the automotive rear light applications based on their LED or OLED driver chips. And also the Vector demonstrated the configuration of CanFD light networks by means of tools. And this in detailed article in the CAN newsletter that is available in the website, in the CiA website. For the future, the CanFD Lite products, always the CanFD Lite improvements are always provided in the CAN newsletter as always. So, to generalize regarding the last slide, the NFT Lite already fits many cost-sensitive embedded applications. Similar architectures are increasingly used in automotive, industrial, and building automation applications. As you can also see here in this photo that it is an example that the typical example application include the measuring sensors, simple actuators, I/O modules, human-machine interfaces. For example, you can see here for controlling temperature, and also the building automotive devices, industrial small monolithic devices, automotive peripheral electronics, and also other applications. The overall ecosystem approach makes the NFT Lite an important building block for future scalable CAN-based systems. What would be the future vehicle architectures of CAN-FD Lite? The future automotive electrical electronic architectures are moving toward a zonal concepts with many peripheral devices. Since computing power is centralized in ACUs and zonal gateways, as well as small sensors and actuators require a low-cost communication solution. Therefore, CAN-FD Lite can help reduce this cost and complexity, where it enables communication with following facilities that no external crystal required, up to 100 responder nodes per commander, and also the monolithic implementation in responder nodes, and daisy chain support with auto addressing, and also it is backward compatible with CAN-FD Lite. And as you can see, for example, here in this photo, imagine a modern car which is facilitated by CAN-FD Lite implementation in different zonal controllers, such as in front zone controller, uh, cabin zone controller, and rear zone controller. If I want to go in detail, the front zone and the rear zone controllers include the front lighting and also front sensing sensors, and also rear lighting and sensors. And also the other example can be the seat controllers and the air conditioners and door modules, that all of them can be implemented by CAN-FD Lite in a cost of efficient way. Now, important question comes up that how would be the future ecosystem and outlook of the CAN-FD Lite? The CAN-FD Lite represents another evolution step toward the scalable communication systems, where lightweight devices and the powerful controllers coexist efficiently by growing semiconductor support, and also expanding development tool ecosystem, more embedded applications, integration into scalable architectures, and also the potential growth in IoT and smart infrastructures. In addition, here the low implementation and network costs, together with a large amount of individual responder nodes that can be connected with CAN-FD Lite, makes it the right choice for this network improvement. With these advantages and properties of CAN-FD Lite in mind, I can say that many additional applications also can be imagined for this cost-efficient and backward compatible network protocol. So, we are almost finishing the webinar, and it would be summarized that the CAN-FD Lite was developed as a simplified implementation of CAN-FD for small monolithic devices with less complexity. And the CAN-FD Lite uses a commander-responder communication schema, and the commander node controls the entire communication, and the responder nodes are only allowed to send data frames if explicitly requested by the commander node. Uh, mm, it supports also a unicast, multicast, and broadcast communication, but only the unicast communication can send request frame. And the CanFD Lite does not support bitrate switching, error frames, and overload frames. The highest speed communication up to 8 megabit per second is possible also using the CAN6 transceivers. And it is compatible with existing CanFD infrastructure and the standards. And it reduces hardware complexity and system cost. And also it enables a scalable distributed architectures with up to 100 responder nodes. There is also a special interest group regarding CanFD Lite that is a subgroup of interest groups, lower layers. If you are interested, join this CanFD Lite group to contribute developing and maintaining the technical documents related to the CanFD Lite ecosystem, and also discuss with experts and bring your idea and comments to develop these corresponding CiA specifications. The next meeting of this special interest group would be scheduled in a short time, and also the agenda for this meeting would be the evaluating the status of the CiA 604-3, and also the new topic about the wake up mode would be discussed in this meeting. If you are interested in this group, you can send an email to the secretary that I have written the address here. In our website, we have a part naming the knowledge base. Always, always the knowledge base of CanFD Lite will be provided and updated in this web page, and that I have also written the exact address here. And now I finished the webinar, and if you have any question, I would like to answer your question.
Hello, can I ask a question? This is Joe.
Yes, of course.
Hello, Mariam. So thanks for this presentation. Very, very much valued. It was quite new to me that CanFD Lite is existing. The first question I would have is just a technical one. You are saying, well, this is really different from all the protocol part that I know from CanFD, like there is no arbitration, there is no acknowledgement, and especially there is no bitrate switching. And nevertheless, you say you can run it at 8 megabit per second. But in the normal CanFD network that I know, you have an arbitration field and a data field. And the data field can be switched by bitrate switching. But the arbitration phase is always as a maximum of 1 megabit per second. Can you explain how this goes together with your statement that 8 megabit is possible in CanFD Lite?
Yes, I go back to the proper and to the corresponding slide. That actually there are some circumstances or conditions about this reaching to the high bitrate mode, and it's about that they are, as I've said here, they are all the possibilities that you can switch them off, or and then to have this possibility to achieve the high bit rate. About the bitrate switching, I can say that a commander node in high bitrate mode shall transmit data frames in the FD base frame format with bitrate switching 0. That it is It means that it is a standardized FD frame with 11-bit identifier. That imagine that, yes, as you have said, in the CanFD frame, we have two different phase, arbitration and data frame phase, and therefore, but in this kind of delight by switching, but by no switching and also no arbitration, you can achieve this with the you can communicate with this fixed bit rate. Actually, I can say, and just with a fixed bit rate, you can communicate. Of course, that it depends on the physical layer, as I have said, but yes, it is possible. No bitrate switching means here that you cannot have different bit rates in the network.
Yeah, yeah. Thanks, Mariam. A simple question at the end. Is it in production in real amps today?
Yes, I showed the production. Yes, here in Audi.
Okay.
Models. Yes, it is you can see this article in detail, and it is written in the CAN newsletter. You can download it in the CiA
Yeah.
website. And a little I explained here that cooperating or the two companies, Marelli, Italian companies, that and also OLED Works, they cooperate together and work on this the rear light or tail lights, and with using connected light network, and then it is now used in Audi. Some of the models of Audi cars, such as Q6 e-tron and also Q3 models.
Okay, great.
And
Launched
and
very recently
also,
in spring. Yes, I can see it. Thank you for that, Mariam.
you're welcome. And also here about the 8-bit rate, it is already demonstrated in the by Bosch last year in the exhibition Embedded World in Nuremberg. We had it. And also in detail, the article also is available in the newsletter June 2025, last year.
Great. Thank you so much.
You're welcome.
Mariam, thank you for the moment. Maybe I can also just come back a little bit to the question, the previous one, with the 8 Mbit. As far as I understood, it's like that in KNFD Lite, you try to remove everything that hinders you exceeding the 1 Mbit. And this was the list that Mariam gave you. It's in part already valid for KNFD Lite up to 1 Mbit, but it will also apply then, or extremely apply then, for higher bit rates. The usage of the CAN-SIG technology will allow or enable the bit rates up to 8 Mbit. And with regard to the tricky point with this bitrate switching, as Mariam has explained, the bitrate switching or the bitrate itself is not adjusted via a bit timing registers in the responder nodes, or not necessarily, but you have an RC circuit maybe, and you have there a synchronization frame that makes them, the responder nodes, understand or makes them or enables them to understand a KNFD frame in the corresponding frequency. And therefore, you cannot have any bit rates which within the CAN frame. So therefore, we have to omit this or avoid this, and therefore is this requirement as explained by Maria.
Okay, thank you, Rainer, for this explanation. But in the protocol, in the frame definition, the bitrate switch bit still exists,
Yes,
but
of
it's
course,
not.
the
Oh,
frame
yes, of course.
format is exactly the same, but you have to say, okay, we cannot allow such a bitrate switching because we have not then the time to send another synchronization frame to the new bitrate and back.
Exactly.
Thank you very much for the explanation. Uh, so, if there is not any other question, I can point out the future webinars about the CAN XL ecosystem we have in the future, and also about the functional safety for CAN-based networks and cybersecurity for CAN-based networks. We have these future webinars in this year. Okay, thank you again for your participation.